Lesson 2.2 is titled Proving Parallel Lines. But what I'd like you to do first is go back to the vocabulary page in Lesson 2.1. I just want a refresher on the types of angles at the bottom of that page. If you remember from this lesson, we had a postulate and 3 theorems, and there was something that was consistent in all of them. We first had an if statement. It says if, and then the picture recognizes that the lines are parallel. Now remember, same side interior angles add up to 180. So if the lines are parallel, then same side interior angles add up to 180. Watch what happens when we scroll over to the right. It's the same idea. For alternate interior angles, it starts off as if the lines are parallel, then we know angles 1 and 2 are congruent to each other. If we look down at the next one on the bottom left, corresponding angles, same idea. If the lines are parallel, then corresponding angles 1 and 2 are congruent. And then one quick refresher over on the right. Again, for alternate exterior angles, if the lines are parallel, alternate exterior angles are congruent. So it's important to note that if-then grouping as we move on to Lesson 2.2. Lesson 2.2 is going to have us kind of working in the opposite order from 2.1 to prove that lines are parallel. Our goal in this lesson is to look at a picture and decide if there's enough given information to verify that the lines we're looking at are parallel or not. A property that we'll use quite a bit is called the transitive property. It says similar to the law of syllogism, which you may or may not know that definition, if A is equal to B and B is equal to C, then A is also equal to C. So notice that B is kind of that common theme in the middle, then A and C would also have to be the same. Now, how that relates to parallel lines is this. In the diagram, it says if angle 1 is congruent to angle 9, put an arc on 1 and an arc on 9. And 9 is congruent to 12. We can also conclude then that angle 1 is congruent to angle 12. We can group those angles together through a variety of definitions, some of them from topic 1, and then again some of them from topic 2. The next big thing we're going to talk about is called the converse of a conditional statement. For an example, if you have a conditional statement, that means it has an if and a then. So conditional statements are if something, then something else. And we saw that in 2.1 with all of those pictures. If lines were parallel, then the angles were congruent. Now it shows you how to create a converse. So here's our example. If a figure is a square, then it has 4 sides. So the statement that's written after if is the first statement. The condition is the arrow right there. And then the second statement is what happens after the word then. So for any first statement, if P then Q, P is just the condition for the first part, Q is the result of that condition. So if lines are parallel, then same side interior angles are supplementary. If lines are parallel, then corresponding angles are congruent. Something like that. But when we throw in the word converse, converse switches the if and the then. So notice now it says if a figure has 4 sides, then it is a square. Sometimes the converse is true and sometimes it's false. So if you think about this, are all 4-sided shapes squares? Not necessarily. But to look at the converse, we're literally just reversing the 2 statements in the if and then form. Our goal is to decide if we have enough information to prove that converse true down below. Like the 4 definitions in 2.1, we have 4 converse definitions in 2.2. If you know corresponding angles are congruent, then the lines are parallel. So notice in L and M on this picture, we don't have the arrows already marked. But if we knew that a pair of corresponding angles would be congruent like that, that would be enough to justify line L is parallel to line M. But if you remember in your 2.1 homework, not every pair of lines were in fact parallel. So this has to be a rule. If corresponding angles are congruent, then we're in good shape with that. Another possible rule is if alternate interior angles are congruent. So remember, alternate interior, they're on the inside of the parallel lines, but on opposite sides of the transversal. If we knew this was true, then we can validate that the lines are parallel. So we just have to figure out a way to tell that that would be a true statement. We have alternate exterior angles. If they're congruent, then the lines are parallel. And that would be something like this top angle on the right and maybe this bottom angle on the left. That would be a grouping to verify or prove that the lines are parallel. And then last but not least, one of the very first theorems that we talked about, or this was the postulate actually, if same side interior angles are supplementary, then the lines are parallel. This time we have an angle and then a different arc for the other angle. They don't have to be the same, but they would add up to 180 degrees. Our goal today is just to try to match up a statement with a picture that relates to these 4 types of converse definitions. Let's look at question 1. Match each figure with a statement that proves the 2 lines are parallel. In the first picture, it says angle 1 is congruent to angle 4. Mark the arcs on your picture and decide, is this a converse for alternate exterior angles, corresponding angles, or same side interior angles? Which one do you think proves this statement true? Angles 1 and 4 are examples of corresponding angles. Therefore, if we know those angles are congruent, this would be the converse of the corresponding angles theorem. If the angles are congruent, then the lines are parallel. All right, let's try the next one. Angle 3 plus angle 5 is equal to 180. So we have this angle here and this angle here. They add up to 180 degrees. Would that be an example of alternate exterior angles or same side interior angles? Take a look at where angles 3 and 5 are located. Notice they're in between the parallel lines and they're on the same side of that transversal. So this example is kind of the converse of the same side interior angles postulate. Therefore, the converse would prove that the lines are parallel. And last but not least, we have one final grouping. Angle 1 is congruent to angle 6. Notice these 2 angles are on opposite sides of that transversal and they're on the outside of the parallel lines. That's an example of alternate exterior angles. For that converse, if alternate exterior angles are congruent, then the lines are parallel. So it's very similar to what we did in 2.1, but kind of just the reverse of that. So instead of saying the angles are equal, if we know the angles are equal, we can justify why the lines are parallel. Here's our next example. A student said that when x equals 6, A is parallel to B. What error did the student likely make? For what value of x is A parallel to B? If we look at our picture, notice the 5x plus 12 is the angle on the left, and the 7x is the angle on the right. So if we plug in 6 for x, 5 times 6 is 30, and 30 plus 12, that angle's 42. On the right, 7 times 6 is also 42. But these angles are same side interior angles. And the rule for those isn't that they're congruent, it's that they add up to 180 degrees. So when it says when x equals 6, the lines are parallel, what is the error? These angles are not alternate interior angles, they're same side angles. So because of that, they're not equal to each other. The student set them equal, to each other. That's the error. What do we know about same side interior angles? If you look back at the postulate up above, instead of those two angles being congruent, we have to recognize that they're supplementary. The next part of the problem says, to kind of fix what they did, for what value of x is A parallel to B? Well, for that to be true, we know that 5x plus 12 plus 7x, if we add those two angles on the inside together, they have to add up to 180 degrees. Now on that left-hand side, do you see how we have 5x and 7x on the same side? If we add them together, we would get 12x. And wow, I so do not have enough space for this for you. I'm sorry. So we have 12x plus 12 equals 180. So what I'm going to do is I'm going to kind of move this over here to the right side of the parallel lines. I know there's not a lot more room for you, but try to make that fit. 12x plus 12 equals 180. And I'm so sorry there's not enough room here. That's just my fault on that. All right, to get x by itself, if we move 12 over, use your calculator or some mental math, 180 minus 12 would be 168. Now, if we divide both sides by 12 to get x by itself, plug that into your calculator and let me know what you get. Go ahead, do 168 divided by 12. Hopefully, you get x equals 14. So if a student were able to determine that, that would prove that the lines are parallel. And that's where we'll end the video lesson. Make sure to show the notes to me when you're done.